Welcome to the debate, where we dive into the big ideas shaping our world, often sparked by the latest research and material we've gathered. Today, we're tackling a concept that's, well, it's everywhere right now, promising to redefine how humans and machines interact. Agentic AI.
Right. It's a term that's become common incredibly quickly, yet it's also ignited a pretty lively, sometimes contentious discussion.
Exactly. And the central question we're exploring is this. Is true agentic AI a present reality? Demonstrably here in significant, maybe still evolving forms? Or is it still an emerging, kind of brittle and domain-specific technology, more future than present?
And just to frame our positions, my colleague here sees agentic AI as unequivocally here, marking a definitive dawn.
That's right. I think the foundational components are firmly in place, already reshaping industries.
Whereas I'll be arguing that truly robust, general-purpose agentic AI, the kind envisioned with its full potential, that remains a future, not a present reality, because of some really fundamental limitations we need to address.
Okay, so diving right in.
I understand why there might be hesitation to declare agentic AI fully here, especially if you're focusing solely on that theoretical ideal of, perfectly robust general-purpose autonomy. However, the foundational architectural patterns are definitively established, and I think we are witnessing its definitive dawn. The current architecture, built around a large language model, which is effectively the AI's brain, augmented by specific memory modules and tools, it clearly embodies the core cognitive loop: perception, reasoning, planning, action, and then that crucial step of learning or reflection. This modular design, even if it feels a bit compensating, it enables goal-directed behavior far beyond simple automation. Consider AlphaGo, for instance. It didn't just execute predefined moves. It discovered novel, creative strategies through deep reinforcement learning and self-play. It achieved superhuman levels of strategic agency within its domain. Now, this isn't just about winning a game. It's a profound insight into how systems can generate genuinely unforeseen solutions. Even enterprise agents, though perhaps, described as semi-agentic or operating under supervised autonomy, they represent a significant advance. They're moving us away from rigid rule-based automation towards more dynamic, adaptable workflows. These systems, I argue, demonstrate genuine agentic behaviors and are already transforming industries. That signifies that agentic AI is a tangible reality in its sophisticated emerging forms.
Okay, I challenge that framing a bit. While yes, the architectural patterns are certainly established, the core question for me is what truly defines agentic AI. And by that, I mean robust, general-purpose, and reliable autonomous goal pursuit. And by that definition, our source material states pretty clearly it is simply not yet a reality. There's quite a chasm between perception and reality, often fueled by what's been called agentic AI washing, essentially marketing hype that really overstates the true autonomous capabilities.
Okay.
Take AutoGPT, for example. It might seem like a compelling proof of concept for an agentic architecture, but anyone who's tried to use it knows it's notoriously unreliable and brittle. These systems frequently, they get stuck in repetitive, unproductive loops. They misinterpret information, and they hallucinate incorrect facts or plans, which leads to compounding errors down the line. Even in areas that seem really advanced, like autonomous vehicles, where the systems are sophisticated model-based agents, they struggle profoundly with novel edge cases, the unexpected things. And they often require a human driver to be prepared to intervene. This just underscores the brittleness of their intelligence when they're faced with the true unpredictability of the real world. These aren't like minor imperfections we're talking about. They are fundamental limitations rooted in the core technologies. And they severely restrict true, reliable autonomy in a way that really matters for practical application. And to elaborate on that unreliability point, I'm simply not convinced that current systems meet the high bar for true autonomy because of this inherent unreliability. Our source material highlights a really crucial point here. These models are inherently probabilistic. They're designed to predict the most plausible next word or outcome. Now that's brilliant for generating text, but it becomes a serious liability when you need precise, factual, and reliable reasoning for real-world actions. This isn't a trivial concern. The problem of compounded errors and hallucinations is, frankly, catastrophic in multi-step workflows. It causes overall task success rates to plummet. Just think about it. An agent attempting a 10-step process, where each step maybe has a 95% accuracy. The overall success rate drops down to around 60%. That's not reliable.
And the very existence of these distinct memory modules and tool use layers, it kind of points to the shortcomings of the core LLM itself, doesn't it? They act as augmentations designed to patch the deficiencies rather than demonstrating some kind of native, robust agency. So how can we really say it's here when robust human-in-the-loop oversight is almost always required for critical decisions, particularly in these high-stakes enterprise applications? This constant need for human intervention, for me, fundamentally demonstrates a lack of true, independent, reliable autonomy.
You've definitely highlighted the critical challenge of compounded errors and the probabilistic nature of LLMs, and it's a valid concern, absolutely. However, I see why you think that, but let me give you maybe a different perspective. Acknowledging that probabilistic nature, the ongoing engineering effort is precisely about building predictable, reliable, and deterministic systems on top of that foundation. The cognitive loop I mentioned earlier with perception, reasoning, planning, and that crucial reflection step is actually designed to self-correct. It's an iterative process. It allows for self-improvement even from an imperfect start.
Okay.
AlphaGo's ability, again, to learn optimal behaviors through trial and error and discover strategies that a human programmer might never have conceived. That shows deep self-directed learning and action within its domain. This isn't just about outputting text, it's about making sequential decisions towards a specific goal. Even enterprise systems, despite the current supervision, which, yes, is often necessary, they are handling complex business workflows, things like autonomously troubleshooting IT issues or screening resumes. For example, you might have an agent that autonomously detects a network anomaly, diagnoses the root cause, maybe even initiates a fix by submitting a ticket and monitoring its resolution, all potentially before a human even realizes there's a problem. This indicates a tangible shift toward dynamic, adaptable autonomy. The need for human oversight, I think, reflects the current state of development and, of course, the imperative for safety in high-stakes environments. It doesn't signal a fundamental absence of agency altogether. It's a spectrum, right? And we're clearly on it.
I hear your point about the iterative loops, but the core issue for me remains. If these augmentations, like memory modules and tool use layers, are really just patching deficiencies, doesn't that reinforce the idea that the underlying LLM brain isn't inherently agentic in the robust sense we're looking for? It suggests, I don't know, a sort of Frankensteinian assembly of parts, rather than a cohesive, truly autonomous intelligence? The source material does emphasize these are shortcomings of the core LLM, not just minor glitches that need ironing out.
Well, I disagree with the Frankensteinian analogy. You could argue that the very existence of these memory modules and tool use layers actually demonstrates human ingenuity in overcoming those limitations, effectively building agency where it wasn't natively present. It's an engineering solution to achieve the desired outcomes. And the fact that we can engineer these systems to exhibit such behaviors, well, that points to the reality of agentic AI today, even in its current form. The goal isn't necessarily perfect native agency from day one, but achieving functional, goal-directed autonomy through clever design. So, okay, we've explored the nature of autonomy and reliability, but let's shift focus a bit now to the scope of this agency. Is it truly general purpose, or is it inherently confined to narrow domains? You brought up AlphaGo earlier as an example of narrow AI, which it is. But I'd argue the source material explicitly frames agentic AI as a highly advanced and more flexible form of narrow AI, not yet artificial general intelligence or AGI. The debate is about whether agentic AI, in this current evolving form, is here.
Right.
The fact that it excels at deep capabilities within a narrow domain, that's a testament to its current reality, not a refutation of its agency. The ability to autonomously orchestrate a sequence of tasks to achieve a broader goal within its specific domain, like, say, an agentic logistics AI, proactively monitoring disruptions, negotiating with carriers, dynamically adjusting production schedules, that is precisely the definition of agentic behavior. It's a crucial stepping stone towards general intelligence, sure, but its current existence doesn't hinge on achieving AGI today. We shouldn't confuse the aspiration for AGI with the current, verifiable existence of agentic capabilities in specialized contexts.
I guess I come at it from a different angle. While I agree, yes, we shouldn't confuse it with AGI, the core of this great debate isn't just about isolated, impressive feats in narrow, closed environments like AlphaGo's 19 by 19 grid. I mean, that system is incapable of transferring its strategic reasoning to basically any other task. It's about the broader promise of agentic AI to tackle complex, real-world problems that aren't perfectly defined. And current models fundamentally struggle with long-horizon strategic planning. They lack the metacognition, that self-awareness of their own thinking process and limitations, and the strategic depth required for truly complex long-term objectives across varied situations.
There's a fundamental memory problem, too. LLMs are essentially stateless, meaning they don't inherently remember past interactions beyond their immediate context. They operate with a finite context window, like a limited working memory. Older information inevitably gets pushed out, leading to a crucial loss of context over time. This inherent limitation, I think, prevents the kind of broad, adaptable, general-purpose reliability that the term agentic AI often evokes in people's minds. It's an active area of engineering and product development for narrow applications, yes, absolutely. But the general-purpose vision, where agents can truly operate reliably across diverse, unpredictable domains, that remains elusive and, frankly, feels like a future, not a present reality.
But isn't the development of those very memory modules and the techniques to manage the context window, isn't that precisely how we're building towards more general capabilities within these systems? I mean, these aren't just patches. They're active areas of research and engineering aimed at overcoming these limitations. The ability of an agent to autonomously perform multiple steps over time, even with a finite context window, suggests it's learning to manage that information effectively within its operational scope. This iterative learning and adaptation, even within constraints, seems like a hallmark of agency to me.
I'd argue it's more like a constant battle against the inherent design constraints of the LLM itself. While those engineering efforts are commendable, sure, they fundamentally confirm the limitation of the underlying models rather than proving some inherent general agency. I mean, if the system needs constant external memory and tools just to function beyond a very short interaction, how truly autonomous or general purpose can we really call it? It feels like needing to constantly restart a computer because its RAM is too small to hold an entire task. It's working, maybe, but it's not truly robust or general in the way we imagine. And that leads us logically to the critical ethical implications. These challenges, in my view, they underscore the immaturity, not the full robust presence of true agentic AI. The whole accountability dilemma arises precisely because existing legal and regulatory frameworks simply cannot cope with emergent, autonomous behavior that is often opaque and unpredictable. We're talking about systems whose behavior isn't easily traceable or even understood after the fact.
That's true. The opacity is a challenge.
Right. And the risk of bias at scale, where agents might autonomously screen and reject thousands of qualified candidates based on biased data, or deploy manipulative tactics in marketing or somewhere else, that risk is magnified precisely because these systems aren't reliably governed or fully understood. These aren't just, amplified risks of existing problems. They are symptoms of systems operating with significant gaps in control, predictability, and safety. This highlights that the technology just isn't robust enough yet for widespread, unsupervised autonomy. If the systems were truly agentic in a reliable sense, these problems would arguably be more solvable through better design and regulation, rather than seeming almost intrinsic to their current somewhat brittle nature.
Okay, I see why you emphasize the unpredictability and the resulting challenges for accountability. That makes sense. However, I would frame the ethical challenges slightly differently, almost paradoxically confirming the active agency of these systems. These aren't concerns about passive tools like a biased spreadsheet. These are concerns about entities that can act on these biases at scale autonomously and often without direct human oversight. The very fact that we are debating an accountability dilemma suggests these systems are making decisions and taking actions with significant real-world impact.
Acts as a risk multiplier, quickly transforming theoretical problems into very real, tangible consequences. This very transformation, I think, demonstrates their capacity for impact and independent decision-making, even if it's imperfect or flawed decision-making right now. Consider goal drift, for example, where an agent might optimize too narrowly on some sub-goal, diverging from the ultimate human intention. The fact that we need robust governance frameworks and human-in-the-loop oversight isn't really an argument against their existence. It's a recognition of their powerful present capabilities and the urgent need to manage them responsibly as they continue to evolve and become more deeply integrated into our world.
I would still argue, though, that if the behavior is truly emergent, autonomous, and critically opaque and unpredictable, then it's precisely those characteristics that define its immaturity, its lack of robustness. The risks of bias at scale aren't just amplified consequences of agency. They expose the current lack of control and deep understanding we have over these systems. If they were truly mature agents, perhaps we would have already built in better mechanisms for transparency and control, making these ethical dilemmas more manageable. The very existence of these profound challenges seems to point to a technology still very much in its infancy when it comes to robust, responsible, and truly autonomous operation in the wild.
But isn't the development of these very governance frameworks and human-in-the-loop systems a response to a present reality, not just some hypothetical future one? We wouldn't be scrambling to govern something that doesn't exist or doesn't have impact. The material we're drawing from highlights that autonomy is here, and its impact is sufficiently real that we need to actively manage its ethical dimensions now. This proactive effort seems like proof of its current standing, not just planning for a future aspiration. All right, so to summarize my position, while the journey to fully robust, truly general-purpose agentic AI certainly continues, no argument there, the current landscape, I believe, undeniably marks its definitive dawn. We are witnessing clear agentic behaviors and transformative potential in nascent, often domain-specific systems. The architectural blueprint, leveraging large language models for reasoning and augmented by memory and tools, represents a profound shift. Agentic AI is here in its foundational and emerging forms. It's already reshaping how industries operate and transitioning AI's role from just a simple tool to something more like a collaborative teammate or digital coworker. The evidence of its impact and its evolving capabilities is simply too strong, in my view, to deny its present reality.
And I'll summarize by saying I still contend that the perhaps grander vision of true agentic AI, defined by robust, reliable, and generally capable autonomous systems, remains very much a frontier of research. While impressive advancements and promising architectural patterns exist, yes, current systems are largely brittle, semi-autonomous, and inherently domain-specific. They're constrained by fundamental LLM limitations we've discussed, like hallucinations, planning deficits, and memory issues. The great debate we've had today is valid precisely because the gap between the marketing perception sometimes and truly realized reliable autonomy is significant. This gap demands continued, rigorous research to overcome these fundamental roadblocks before we can truly say agentic AI and its full, reliable potential is a present reality, rather than a powerful but still emerging technology with quite a way to go.
And I think we both agree that the value of considering these multiple perspectives is immense.
Absolutely. There's clearly much more to explore in the rapidly evolving landscape of agentic AI.